folks, and welcome to this episode of Geography Talks. If you are new, please subscribe to the channel to keep up to date with more content. And if you're enjoying this series, then drop a like on the video. Today's episode is going to focus on folding and faulting for the Leaving Cert Geography exam. I'm going to talk you through the main points, some of the things that you could possibly put in then to your essays. I suppose one of the first things you start with when you're doing any essay on plate tectonics, be that folding, faulting, volcanoes, or earthquakes, you want to put in something about the theory of plate tectonics itself. So something that I like to get my students put in is to say plate tectonics is the theory that the lithosphere, which is your crust, consists of large rigid sections called plates, and go on to say that these plates move slowly with respect to one another. And then I would add into that convection currents in the mantle are the driving force behind plate movement. So you've got it all there in the space of about, I'd say, 3 sentences. And that's your theory of plate tectonics. Now, after that, then you'll write a small bit, depending on what the question is asked. It might ask you about how the theory of plate tectonics helps us to explain the occurrence of fold mountains or fault lines. And so you'll need to do a bit of a link in that regard. But I'm going to jump straight ahead and I'm going to look at folding and faulting itself. And I'm going to start by looking at the 3 forces that are involved in folding and faulting. I mean, what folding and faulting effectively is it's rock deformation. And so what you've got 3 main forces that are involved in the deformation of rock. So the first one is compression. It's quite thrown off. So it's basically where the rocks get squeezed together and the body of the rock itself gets shortened. So if you can imagine picking up a piece of paper and just crumbling it up, squeezing it together, that's your compression. Tension then is when the rock gets stretched. So take your piece of paper and just pull it apart. The tension that you create when you try to pull that paper apart effectively breaks it, and that's exactly what happens with the rock. Now, sometimes the rock doesn't necessarily always break, it just gets stretched out. And the final one then is shearing. So shearing is when the rock is dislocated, and this is what happens when the rocks start sliding past one another, and that's mostly associated with faulting. So think of it almost like your transform plate boundary, where you have 2 plates sliding past each other. Shearing is one of those forces where the forces are going in opposite directions and it dislocates or breaks the rocks, is basically what's happening there. If we sort of break it down further then and look at folding. So folding is when the collision of tectonic plates places huge pressure on the rocks on the Earth's surface. Primarily will happen at a destructive plate boundary. I say primarily, it pretty much always happens at a destructive plate boundary where 2 plates are colliding. Those rocks, usually on the lighter, more continental plates, they are forced upwards and they buckle, which basically means they fold back on themselves, which is where they get their name. As you know, then we call the upward ridges anticlines, and the valleys or the downfalls will be called synclines. And fold mountains, they're mountain ranges that have been formed from folding. They can reach sometimes heights of 9,000 meters, but they do get worn down over time due to weathering and erosion. So our Himalayas, Mount Everest, that would be an example of a fold mountain. I think it's just over 8,800 meters high. But we consider the Himalayas to be a young fold mountain range. It's part of the alpine folding about 35 million years ago. It hasn't had the chance to be worn down yet, but over time it will, and those mountain peaks will get smaller. You know, that's the way it just works. If we want to dig in a bit more then and we look at the different types of folds, the first one I'm going to look at is a symmetric fold. Obviously I can't show you or draw it for you, but a symmetric fold, it's kind of what it says in the paper. It's symmetrical. It's formed when the pressure that is applied from each side is gentle and equal. So you've got equal amounts of pressure coming together, and so you get a smooth upward curve. So everything is nice and even in the rock. That is in contrast then to an asymmetrical fold, and this forms when pressure on one side of the rock is greater, and so it gives it a sort of an uneven look. That's probably the best way that I can describe it. The third one you have then is called an overfold. So this is formed when you get extreme pressure on one side of the rock, and basically, like the name suggests, overfold, it folds back over on itself. And sometimes if that pressure is so extreme, your overfold will become almost horizontal, and then it's called a recumbent fold. But they will be our main types of folds. They're the main things you see in a mountain. If you cut a mountain down the middle, you'll be able to see the type of fold that is happening there. As I might have mentioned earlier on about when I was talking about the Himalayas, you've got 3 different types of fold mountains altogether. Now, the formation of fold mountains altogether is called orogeny, if you want to jot that down as one of your smart keywords. The 3 different types really are your Caledonian, which formed roughly 400 million years ago, Armorican, which is somewhere about 250 to 300 million years ago, and then you've got your Alpine, which is 35 to 50 million years ago. And then obviously, both in Ireland and abroad, you're going to have different examples of them. From a Caledonian perspective, the Dublin Wicklow Mountains are an example there. They're the really old ones. And what you also find is the Appalachians in North America, on the east coast of North America, the Dublin Wicklow Mountains in Ireland, and the mountains in Scandinavia up along the west coast of Norway. They're all Caledonian mountains. And if you think back to your continental drift, your theory of plate tectonics, the rocks that were found in those mountains proved that they were all formed at the same time. So at one stage, those are all part of one mountain range. And then as the plates moved, as continents moved, they separated, and now they're separated by an Atlantic Ocean. The Armorican folding, or second type, sort of the middle age, if you want to call them that. The Munster Ridge and Valley would be a prime example of that here in Ireland. They're old enough that they still have a bit of height to them, but they're also old enough that they have been worn down. So in the Munster Ridge and Valley, for example, you have seen that the limestone on top has been eroded, and you now have the red sandstone coming through. The newest fold mountains, the Alpine folding, as we said, the Himalayas, a key example of that. The Alps as well as one. I mean, that's probably the easier one to remember because it gets its name. Alpine folding, the Alps. It just makes a little bit easier for you. So I'm going to break that down a little bit more now in terms of the fold mountains in Ireland. So orogeny, as I said, is what we call the formation of fold mountains. It's responsible for many of Ireland's mountain ranges. Our oldest mountain ranges, they were formed in the Caledonian period over 400 million years ago. That's the Dublin Wicklow Mountains. That was due to the collision between the American and the Eurasian plates. But if we think to modern day plate tectonics, we know that the American, or specifically the North American and the Eurasian plates, they're actually separating now. So just, you know, it's another example here of how our plates are constantly shifting and moving. But that collision 400 million years ago, it caused large parts of the rocks in Leinster to buckle and fold, and that led, as I said, to the Dublin Wicklow Mountains. Now, they have been worn down over time due to weathering and erosion. Now, we did actually get our Armorican folding in Ireland about 300 million years ago, and that was when the African and the Eurasian plates collided, and that time we got the McGillicuddy Reeks. So within the McGillicuddy Reeks, the counties down in Cork and Kerry, you also then got the Munster Ridge and Valley, which, as a fun fact, you've got the rivers Lee and River Blackwater. They flow through the synclines or the valleys in the Munster Ridge and Valley. On the other side then, because obviously it's not just folding we talk about, and that can be a mistake that a lot of people make. They talk just about folding. Faulting was also there. And faulting occurs when pressure on rocks forces them to crack along a fault line, and that results in the movement of land. So like folding, we've got different types of faults. I'm just going to talk about a few of them for you. So a normal fault occurs when rocks within the crust are basically subjected to tension at a constructive plate boundary. So this is when plates pull apart. So this leads to the stretching and thinning of the rock, and eventually the rock fractures and the movement of land is downwards. So at a normal fault, at a constructive plate boundary, land moves downwards. And there's actually an example of this in Ireland up near King's Court in County Cavan. The second type of fault that we're going to look at is a reverse fault. And these occur when the rocks of the crust are subjected to compression at destructive plate boundaries. So this is when plates collide. And that compression causes the rock to fold upwards. But rocks can only fold a certain amount before cracking. And an example of that fault can then be seen running from Killarney to Mallow. So a question you might get might be to ask you to talk about features that result from folding and faulting. So obviously folding is straightforward, you get fold mountains. Faulting, well, for faulting, you're going to get block mountains. So if you think of the Ox Mountains in Connacht, that's where land between two parallel faults, so they're faults that are beside each other, got forced upwards. So that's where you see your faulting in Ireland. Something that's nice then to add in, a sort of an international taster, if you like, into your essay. The Great African Rift Valley. And this, I think, is becoming one of the most interesting geological concepts that's out there right now. A rift valley, I suppose, to break it down, that gets created when crust is pulled apart and the land between them sinks or falls down. The African Rift Valley is one of only 2 continental rift valleys that exist. It has numerous volcanoes. Mount Kilimanjaro is there, Mount Nyiragongo is there, which we talked about in the previous podcast. What's happening there is, well, or I suppose what happened was about 400 million years ago, Eurasian and African plates collided, and that actually weakened the crust on the African plate, and it caused a fissure, which is basically a crack along a plate. And then at that fissure, we've started to see a rift valley called the African Rift Valley forming. Some fun facts about it: it's about 4,800 kilometers long, and you know it's getting bigger. That's the thing. So basically, what happened, I suppose, was huge pressure built up in the molten magma, and magma rises up to cause a dome in the Earth's crust, and this causes your huge parallel faults to occur. And the African Rift Valley formed when land between the faults slipped downwards as tension pulled the plates apart. And as I said, the separation is ongoing. Already what's happening in some places, the rift is starting to fill up with water, and it has already created lakes such as Lake Tanganyika and Lake Malawi. This is also how the Red Sea separating the Arabian and African plates, and also the Gulf of Aden were formed. So they were formed through rift valleys as well. Now, as this crack continues to widen, in about 50 million years' time, some of us may be around. Doubt it, to be honest. But basically, Tanzania, Kenya, and Somalia will split from the rest of the Africa, and there will be a gulf between them. So the fissure will fill with water, and we'll have probably a new sea being formed. But I suppose that's tomorrow's problem to deal with. So look, I hope this has given you a bit of a quick summary, quick revision on folding and faulting in Ireland. Remember that this is not supposed to be designed to be an essay. It's not supposed to be the be-all and end-all. You know, use the notes that you've got from your teacher. Use what's in your book when you're writing your essays. But this is, I suppose, supposed to be a quick and handy revision guide for you to use. If you have any suggestions for future videos, make sure to leave them in the comments below. Like this video if you've gotten some use out of it. And of course, subscribe to support the channel. And we can get more videos like this. But for now, thank you very much for watching.